Today we're tackling some machine learning and integration concepts for the IBM C1000-204 exam that can, really trip people up in practice.
Yeah, we're covering how to pick the right storage for Kafka, securing air-gapped deployments, and dealing with network latency.
Let's jump right into some real problems so you can see how these topics get tested, starting with storage.
Okay, lay it on me.
So if an architect is using OpenShift Data Foundation, what storage type best supports high-throughput Kafka logs in IBM Event Streams?
Well, a lot of folks see cloud native and immediately want to guess option A, using object storage with S3 compatibility. It's a huge trap because S3 scales endlessly.
Wait, let me think about this. S3 is great for backups, but Kafka needs raw transactional speed for persistent messaging, right?
You are right on the money.
So wouldn't block storage with read-write once or RWO access be way better?
Spot on, yeah. RWO means the storage is mounted read-write by a single node, which gives you an exclusive, dedicated connection.
Oh, so in the real world, block storage with RWO is kind of like a dedicated high-speed factory lane just for your data?
Right, exactly. Whereas S3, or using tape backups, are just completely the wrong fit because they are way too slow for a persistent messaging workload.
That makes sense. Speaking of infrastructure, let's look at restricted environments. When planning the Cloud Pak for Integration Image Registry in an air-gapped setup, what registry location consideration is absolutely critical?
The cognitive bias here is definitely familiarity. People are so used to AWS or Azure that they just assume the answer is A, running on a public cloud provider.
But air-gapped literally means it is physically disconnected from the outside internet.
I know, so public cloud is entirely out of reach. The real requirement is option B. The registry must be accessible by all internal cluster nodes.
Oh, I see, because if your worker nodes can't reach that internal registry, your deployments just flat out fail.
Yes, and you can't rely on temporary storage or remove it after setup either.
Right. Registries need persistent, reliable state to serve images continuously to those nodes.
Exactly. So if all nodes need that internal access, how do we actually restrict pod traffic?
Like how OpenShift provides network isolation between different integration namespaces.
Yeah. I've actually seen organizations get so paranoid they try guessing option A, deploying physical firewalls between worker nodes.
That feels way too heavy-handed.
It really is.
The native Kubernetes approach is using network policies to restrict pod communication, right?
Spot on. Network policies are like internal key cards for different departments in a big office building.
You don't build a physical moat, like a firewall, inside the lobby.
Right, exactly. And whatever you do, don't try to disable the software-defined network.
Because that would just break your cluster's entire networking capability.
Exactly. So once you have those network policies locking down the perimeter, you actually have to deploy your integration tools into that safe space.
Right. So what is the role of integration assemblies in Cloud Pak for integration deployments?
Well, having done a lot of legacy migrations, I know developers get tempted by option C, using legacy migration scripts like moving from IIB to ACE.
It sounds plausible for sure.
It does, but an integration assembly is actually B, declarative definitions that deploy multiple integration capabilities as one single managed unit.
I love that. It's like a blueprint for a whole neighborhood, not just one single house.
Beautifully put. Trying to manage them as physical appliances or internal Java classes is just the wrong level of abstraction entirely for modern Kubernetes.
Okay, so after deploying that whole neighborhood, we obviously need monitoring.
Definitely.
Imagine you need historical dashboards showing API throughput and latency over the last 30 days. Which API Connect subsystem provides this?
Throughput. I'd instinctively look at option C, the gateway subsystem.
Oh, that's tricky.
Wait, really? Because it handles the actual traffic routing.
Right, but the gateway is basically the toll booth processing the cars. It's not keeping the historical traffic ledger. That's actually option B, the analytics subsystem.
Ah, right, of course. Analytics keeps the 30-day ledger.
Yep, and you wouldn't use the management or portal subsystems for this either.
Because those are strictly for operational configurations and developer access, right? Not historical traffic history.
Exactly. Now, what if you have multiple tools to manage across this entire decentralized architecture? Which capability provides a unified entry point?
People usually default to option C here, the OpenShift console, just since it's the cluster's central hub.
True, but OpenShift manages the underlying containers. For the actual integration tools themselves, it's option B, the platform navigator.
Oh, right. That platform navigator is basically a universal remote for all your Cloud Pak tools.
Yeah, relying on something like the MQ console is way too specific to one product.
And OpenShift is just way too broad.
Exactly. Let's pivot back to storage for a quick caveat. Say a customer uses Azure File Storage for read-write-many, or RWX, requirements.
Okay, I'm following.
What common performance issue affects frequent small file I/O?
Well, file systems always clash, so my first thought is option B, a lack of Linux ext4 compatibility.
It's actually option A, network-based file protocol latency.
Wait, why does a network protocol struggle with small files?
Because of the constant back-and-forth handshake required.
Oh, I see.
Sending 1,000 separate small files over a network protocol is literally like mailing 1,000 individual envelopes instead of putting them all in one big box.
Wow, yeah, the network overhead just completely kills your performance there.
Exactly. Things like license metric tools or auto-deletion features are just completely irrelevant traps in this scenario.
That makes perfect sense. Speaking of heavy I/O, what storage type is explicitly required by the Keycloak database?
Well, S3 object storage is super popular for apps, maybe that.
Actually, databases need dedicated exclusive read and write capability, so it requires option D, block storage with RWO access.
Oh, right, because RWO guarantees that fast exclusive connection.
Exactly, and S3 completely lacks the transactional write access a database needs. And you definitely wouldn't use read-only many, or ROX, because a database fundamentally needs write access to function.
That's all the key points we shared for the IBM C1000-204 exam today. Thanks for watching, and if you found this helpful, subscribe and leave us a comment.